Hello. In this video, we're going to work on some algebra questions that involve factorials. But before we do, let's start with just a very basic algebra question. Solve n equals 3n minus 6. A question like this, I think we can all handle. We subtract n from both sides, add 6 to both sides. That's going to give us 6 equals 2n, divide by 2, and n equals 3. Okay, let's compare that to this question. Solve n factorial over n minus 1 factorial equals 3n minus 12. Now initially this might look like a very challenging question. There's factorials, you're going to have to do multiply, all sorts of things. But remember that if we had 10 factorial over 9 factorial, for example, we could write this as 10 times 9 factorial. Cancel the factorials, and we just get 10. So if we have n factorial, we can write that as n times n minus 1 factorial over n minus 1 factorial. Cancel the n minus 1 factorials and just get n. In other words, that left side reduces to just an n. Again, the reason is n factorial means n times n minus 1 times n minus 2 times ... all the way down to 3, 2, 1. But we don't have to write all of that. We can kind of break off the n and then write the number below n. Another way of thinking about it here is what we did with the 10, was the number 10 is here and the number 9 is here. So we broke off the 10 and then wrote 9 factorial. The reason we write 9 is because 9 is the number below 10 if you count down. So if you have the number n and you're counting down, the number below n is n minus 1. So you break off the n minus 1 factorial. All right, with that in mind, we now have a regular algebra type situation. We can subtract n from both sides. We can add 12 to both sides. 12 equals 2n, and n equals 6. Now, I'd encourage you to pause the video and check this answer. See if it makes sense, see if it works out. All right, so we could go ahead and check it. We would get 6 factorial over 6 minus 1 factorial. 6 minus 1 factorial equals 3 times 6 minus 12. Well, 6 factorial, we can just 6 times 5 times 4 times 3 times 2 times 1. 6 minus 1 is 5, so that would be 5 factorial, 5, 4, 3, 2, 1. Those all cancel. And we just get 6. On the other side, we would get 3 times 6, which is 18. And 18 minus 12 is 6. So yes, it checks out. All right, pause the video and see if you can solve this one. N factorial over n minus 2 factorial equals 5n. All right, so assuming you gave it a try, we again are thinking about the number n, and we want to break it off. So we could do n times n minus 1 factorial, but that's not going to cancel with the n minus 2 factorial. So what number is below n minus 1 if we wanted to break off another term? The next number, if we're counting down, is n minus 2. So we don't actually write it as n times n minus 1. We write it as n times n minus 1 times n minus 2 factorial. We have to break off 2 terms because we count down 2 times before we find the thing that cancels. So this gives us n minus 1 equals 5n. We expand to get n squared minus n equals 5n. N squared minus 6n equals 0. So you have n minus 6 equals 0. Whenever we're doing a degree 2 polynomial, we move everything to one side, factor solve. This gives us the solution n equals 0 and the solution n equals 6. Now we have to check here. Both of these solutions are possible for the algebra, but they might not be possible for the original factorial question. If we look at the 6, we're going to get 6 factorial over 4 factorial. So we can check that one. So let's check n equals 6. 6 factorial over 6 minus 2 factorial. And the other side should be 5 times 6. So here we're going to have 6 times 5 times 4 factorial over 4 factorial. So we get 30. And here we get 30. So yeah, that checks out. But what if we check n equals 0? Well, for this one, we get 0 factorial over 0 minus 2 factorial. This should equal 5 times 0. Well, 5 times 0 is just 0. 0 factorial is a 1. But 0 minus 2 is negative 2 factorial. And negative 2 factorial, this is undefined. We are not allowed to do factorials of negative numbers, which means that n equals 0 is actually a solution we have to reject. So we reject this solution, but we accept this solution. This is similar to when solving square roots. Sometimes you end up with these extra solutions that aren't real. Sometimes they're called extraneous solutions. In this situation, we have the same problem. There's a domain issue for n. N can't be negative numbers. And so if you get a negative number, you have to reject it because it's just not going to work. Now you might say, well, Mr. Peters, n equals 0 is not a negative number. That should be fine. Well, be careful here. It's not that you get a negative number for your n. It's that you get a negative number for your factorial when you plug in the n. So in this case, even though 0 factorial worked on the top, you have a negative 2 factorial on the bottom when you substitute it. All right, let's solve n plus 1 factorial over n minus 1 factorial. Again, I encourage you to pause the video and give it a try. All right, I'm going to draw a little number line here. We're at n plus 1. What number is below n plus 1? That's going to be n. And then below n is n minus 1. So we can expand this as n plus 1 times n minus 1. That's a good place to stop. So we put n minus 1 factorial, and we can cancel that out. That's going to give us n plus 1 times n. So n squared plus n minus 6 equals 0. Factor that down. N plus 3, n minus 2. Okay, so that gives us n equals negative 3, and that gives us n equals 2. We have to check. So let's check n equals negative 3. It's going to give us negative 3 plus 1 factorial on the top over negative 3 minus 1 factorial on the bottom. Right away, we notice that we're going to get a negative 4 factorial on the bottom and a negative 2 factorial on the top. This is undefined. This is all sorts of problems, so this gets rejected. How about n equals 2? You have 2 plus 1 factorial over 2 minus 1 factorial. On the other side, you have 6. That's going to be 3 factorial over 1 factorial. That's going to be 6. Yeah, that checks out. All right, so one of the answers worked, one of them didn't. Now, sometimes the factorials are given to you with a bit of a different style. This says NP2 equals 56. And if you check on your formula sheet, there's something for NPR. This is a formula that involves factorials. It's called the permutation formula. We don't tend to use it a whole lot when solving problems, but it's interesting, and it allows us to write the following. NPR means n factorial over n minus r factorial. In other words, we could write this as n factorial over n minus 2 factorial equals 56. So it's the sort of same thing we just had, but there's an extra step of recognizing that this is from our formula sheet. All right, pause the video and see what you come up with. Okay, so you should get n minus 1, n minus 2 factorial over n minus 2 factorial. Those cancel. So you get n squared minus n minus 56 equals 0. Looking for two numbers that multiply to give 56 and add to give negative 1. Thinking 6, 7, and 8. So if we have negative 8, positive 7, that gives n equals 8, n equals negative 7. We can see right away with the check n equals -7, that's not going to work. -7 factorial on the top, -9 factorial on the bottom. This is undefined. So we reject that. But if we were to check n equals 8, that's going to work out. Yes. Now, if you want, you can actually check this on your calculator for your final step. If you do 8p2, you should get 56. You're looking for the P button. It's NPR, just like this over here. It should be underneath your multiplication sign if you have the Mr. Peters approved calculator. So you hit Shift multiplication and you'll get the NPR. You have the 8 first and then the 2 second. So you would actually type this in on your calculator as 8 shift times 2. It equals, and you should get 56. So your calculator knows about this formula, and it's interesting to check your work if you have a calculator. All right, one more. We have NP2 equals 30. So I'd encourage you to pause the video and give this a try. All right, so we get n factorial over n minus 2 factorial equals 30. And n minus 1, n minus 2 factorial over n minus 2 factorial equals 30. Cross off the factorials. N minus 1 equals 30. N squared minus n minus 30 equals 0. N minus 6, n plus 5. N equals 6. N equals -5. We can see here that the -5 is going to lead to a problem. So this is going to get rejected because you're going to have -5 factorial. This is going to get accepted. All right, so let's go ahead and take some notes on this. So this is solving factorial equations. And the basic idea for these questions is if you have a factorial over a factorial, you're going to expand the larger factorial. I use expand in air quotes here. And then you're going to cancel. And then you're going to solve with normal algebra. And then you're going to check your answer. So for example, right, if you had n factorial over n minus 2 factorial, this is the same as n minus 1, n minus 2 factorial over n minus 2 factorial. So this step right here, this is either, you can think of it as breaking off the terms, or you can think of this as like your expanding step. All right, let's put up an example here. So let's solve NP2 equals 10n. So pause the video and give that a try. All right, so this is first off a formula, n factorial, n minus 2 factorial. Then you get n minus 1, n minus 2 factorial. Then you get n squared minus n minus 10n. So you get n minus 11. So n equals 0 and n equals 11. The n equals 0 gets rejected, and the n equals 11 gets accepted. So you can go ahead and try another example from worksheet 7 or 7.5. 7.5 has some additional factoring review in case you need a little practice on the factoring. And then you can write down any things to remember. Again, probably the most important thing to remember here is that a negative number inside a factorial is undefined. So if you ever get that, you know you have to reject the answer. Another thing you might want to remember is that if you're breaking off larger numbers, for example, if I had n plus 2 factorial, you could write this as n plus 2 times n plus 1 times n factorial. So that would be, let's say it was over top of an n. That's how you would end up with what you need to cancel out. So again, you kind of count down. So n plus 2, the number below that is n plus 1, and then n, and so on. All right, hopefully you enjoyed this video, and as always, thanks for watching.